Hello, I'm finally back to the standard setup here, and now I'm doing this one problem that talks about that quadrilateral inside another quadrilateral. I need to find the possible side length. So I think it's a good idea to draw this quadrilateral first. So I got this rectangle that the ABCD will be inside, and then we get AB and then DA and then CD. Going to go label the sides as shown, as well as the lengths of them. I can see what was going on over there. I see that there's going to be 4 right triangles that are going to be used to form that triangle, and I think I'm going to need to find the possible lengths and stuff. 15, 13, and 5, we can possibly do something like x squared plus y squared equals 225 or something like that. I think you could eventually find that the only triangles that would work are the 9, 12, 15 triangle, or the 3, 4, 5 triangle, or the 5, 12, 13 triangle. They all look familiar, those triples or something like that. So now it's a matter of thinking about how to rearrange those 3 triangles that I have, those 3 triangles, and putting them together to figure out how to see what possible fourth sides there are.
So I have a 3, 4, 5, 5, 12, 13, and 9, 12, 15 triangle, and I'm trying to piece them together such that the side lengths are together, like this pairs with this side, as well as this side being paired with this side to form that quadrilateral. So how do I put these together? Okay, let's put this pieces together just like that, and another piece together like that, such that we are forming those straight lines that are sides of these rectangles. And then using the segment addition postulate, we can add them up. And then additionally, from these other sides, we can find out the missing lengths that I'm pointing out right there, and then use that to find the length of the hypotenuse via Pythagorean theorem. So for this one, putting together the 12 and the 4 side results in a side length of 16. Putting together the 5 and the 9 side give you a length of 14. And then using the other side lengths to get that this side is 11 and this side is 4. That's one possibility. But now I need to think about what happens if we could arrange the triangles in some other way, like what I'm doing right now with flipping that triangle. So now the length of one side is still going to be 16, but that other length side is going to be 17 instead. And now those new lengths are going to be 7 and 14 because we're subtracting different sides. And this is for that hypotenuse right over there. But we could also flip that run rectangle right there and then get that the one of the side lengths of that big rectangle is going to be 15. The other side lengths of the big rectangle is going to be 17 still. But the side lengths of the triangle that we were looking for is 13 and 6. And that is going to result in this hypotenuse right there. And finally, we could even flip that other triangle right there. And then as a result, when we find this hypotenuse right there, we're going to use the sides of this rectangle of length 15 and length 14. And then this triangle is going to be 3 and then 10, again, subtracting sides. But then there's even more possibilities I could consider. Like, what if we flip this 5, 12, 13 triangle to have it be oriented like that? Well, looks, I'm not able to find a triangle and put together, no matter how I orient it. Like, that's the lengths are going to be stuck outside, and it would not be able to form the rectangle. And even if we flip the 3, 4, 5 triangle like that, it's not going to be a valid case because the vertex can't touch the vertex of the rectangle. So either way, there's no more cases, and we are done with finding the cases.
All right, got back from writing down all those cases and keeping them in an organized list such that everything's all easy to find. And now I can just use the Pythagorean theorem to find the length of the third side, but since we're only caring about the possible values of BC squared, we don't even have to worry about square rooting this time. So 10 and 3, 100 plus 9, that will be 109. And then 11 and 4, 121 plus 16, that's going to be 137. And then 14 and 7, that's going to be 196 plus 49, or 245. And then finally 13 and 6, which is going to be 169 plus 36, which is going to be 205. And then we add them all up to get that the sum of the possible values is going to be 686. All right.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.